Now I've just finished milling operation here, and I've made this 1 inch and 5/8, 1 inch 1 inch 625, and when I check between here and here, I seem to have a discrepancy of about 5/1000ths of an inch when I measure it this way, over 2 3/4 inches. So I imagine this may not be quite right on the dividing head, because it has a fourth axis that will turn, and it might be slightly out. But I'm done with this part now. I'm going to take it out. I'm going to cut this off, put it in the lathe and bore it, and then get ready to set it up in the shaper. The blank has been cut off, and I've just machined it round and bored through it, and I'm 20 thou over the minor diameter of the shaft it's got to go over. And next step will be to actually make the cutter tool for the spline on the shaper, and square up the jaws on the shaper chuck, and we'll go from there. I have started trying to cut a spline, actually a 6-tooth spline or 6-point spline inside this piece of 1045 steel. And I've never used a shaper before, so one of the issues that I have, this was for the indexing, the hex that I made on it. I can turn it around later. Here is the tool I'm using, and as you can see possibly at the bottom there, my thought is to be able to just put this all together. This is how it would index it inside here. It would be clamped, and it would machine that just like that. The issue I find is that the cross section, this is a 5/16 tool, doesn't have the down pressure, plus the fact that the steel is relatively hard. It's like I said, 1045 instead of a 1008 or 1010, 1012. So what I've had to do is kind of push on it a bit as it goes back and forth. Well, you know, working around machinery all your life, one of the things you don't do is put your fingers where anything's moving, and even adjusting the amount of cut, you have to do it while the machine is reciprocating back and forth, and I find it very unnerving. So I think what I'm going to have to do here is change this tool so that it cuts just the narrow portion of the center, or maybe even a little bit less, and then go in after with this cutter, just because the machine doesn't have the mass to be able to handle what I'm trying to do with it. Possibly if this was shorter it would have been you know, easier, but it does work. We'll get into that in a little bit, but it's a learning process, and I'm sure I'm doing something wrong, as I've never run a shaper before. One other thing I did, I noticed when I first started doing this cut, I didn't have this bevel on here, and at times it would grab and stall the machine. So I did take it and put it in the lathe and put a bevel on it. But I'm just noticing now, I was having some problem. I'm only in about 50 thou. I've got to go about another 100 thou. And I've noticed that I'm at the end of the bevel, and I was having some problems with it grabbing. So what I'm going to do is put more of an extensive bevel on here, so that just lets the tool, instead of coming up against a dead abrupt shoulder, it's got a little bit of a taper so that it can get into the groove. So what I found is that first off, trying to make an adjustment on this with my hand moving, I get kind of nervous. There's lots of places to get your fingers pinched, and I find it somewhat upsetting. So maybe it's because the metal is hard, but what I've done here is that I've put a smaller tooth on it to try to take a little bit more material, or a little less material, rather than cut with one big cutter that's the profile of the tooth. So what I'm going to do now, I'm going to shut this off. I'm down, I did check it, I was down around 100 thou, which is what I want, and I'll shut this off and change the tool on it and try to cut out this first tooth in the spline. Well, I've changed the tools over, and I have now gone to the bottom depth, which I took out with the small tool before. One of the things I've noticed, everything seems to get loose. The gib on here was wiggling, this was wiggling. I forgot to tighten this up, made sure that the foot down here was set up. So again, it's a learning process. I've never run a shaper till now. And of course the machine was all taken apart, and I haven't used it on anything substantial such as this. So I'm going to now reclock this, take this out, change it, and start on the next spline or tooth or notch, keyway. Not quite sure what the proper term is. I have been messing with this for a bit, and it isn't without its problems. It would have been nice if it was closer. One of the problems, or the table was farther. I have seen people have made extension tables. Also an indexer would be nice. However, it would have to be really robust because this metal is hard. So what I ended up doing is laying out a template and putting center marks so that when I've got this in here, I can adjust the cutter. Now this is the first cut to try to take out some of the bulk because it's just too much meat for this little machine to try to take out in one pass. And one of the issues is that you can move the cutter here to the side, you can angle it and whatever. So trying to get that all sorted out, and like I said, this is the first time I've ever used this machine for anything that had a purpose other than I had a piece of cast iron block in there and I planed it across. I also put some rake on the tool, hoping that would help. But one of the problems is once it hits this metal, the cutter once it hits it, it bounces and it settles back down. So I've been forced to try to hold it down a little bit to give it a little more bite. This 1045 is definitely proving to be problematic. Well, I've taken this again and rotated it and rotated it. I didn't bother because while I'm doing it, I'm actually standing in front here and giving it some down pressure because it wants to dance. I think just because the metal's so hard. Anyways, I'm going to take it out. I'm going to try to fit it. I don't expect it to fit right away. I imagine I'm going to have to do a little bit of playing around, but that's okay because it's going to be better than what was in there from before. Okay, I've done a little monkeying around with this. Well, there's a little bit how it looks. Whoops. I've got it on zoom so I can have it in this area, but I'll take a picture of it after. But anyways, I do have it, figured out to put it on to match what's here. It looks like it's pretty good. I can give it a little bit of a tap. That's about it. It shoulders out. To take it off, just give it a little bit and it'll come off. So this is a lot better than what I have on the other one. So now I'm to the point where I've got to transfer this onto the drive shaft. For some of you guys who say my shop is pristine here, you're nuts. Look at all these piles of tools and stuff everywhere. It bugs me. Anyways, this is a drive shaft that comes out of the clutch and has a pilot bearing at this end. And I've just drilled it so it's going to be the same length. It's 31 1/8 of an inch long. And I'm going to cut this drive shaft off here, clean it up a little bit to get the rust off of it, and then I'm going to bore this coupling to that diameter, and then I'll weld it around. But I'll set it up on the lathe and make sure I've got it centered and everything's true. I have the drive shaft chucked in the Harrison. The The through bore on this is 1 inch 300, and the drive shaft at the clutch end is actually 1 inch 350, I believe. But it's enough, it's big enough for me to get the 1 inch 300 all the way except for the very end, so it allows me to trim this off in square. This is the original coupling. It's worn, and what I've done, if you can take a look inside, possibly we can get that here, we can see that they're doing exactly what I wanted to do. They've inserted the shaft inside, and it's probably pressed in a bit, and the weld is only stopping it from slipping out. So it's just not a straight weld that's taking the strain of the torque. So that's what I'm going to do. I've trimmed this off, I've cleaned it up, and I'll mic it afterwards, and I'll bore out the new coupling. Well, one of the things I've noticed here, and before I can go any farther, is I've got end play that I have to deal with. So I'll have to get a dial gauge out and check that. And behind this plate are some shims, and that seal was leaking, so I've already got a spare one, so I've got to change that as well. So before I can do the fitment and the welding, and I want to check the run out of the new coupling I've made, I have to make sure that this isn't moving back and forth like it is, and they're on taper roller bearings, so I got to fix that. Well, set up here with the dial gauge, and it shows right now I have about 23 thousandths of an inch of end play, so that means I've got to take 20 thou of shim out from behind here, so that will be my next challenge. What I did with this coupling is I put it on the input shaft of the transmission, put a dial gauge on it, and rotated the transmission input shaft, and I came up with it being 5 thou too high. So now what I've done is put this in the lathe and put in shims so that this point again is 5 thou too high, so that'll be the accurate center for this bore and the drive shaft tube to be put in. This is the shot after I've machined out to 1 1/4 inch, and I'm size on, so we'll see where that goes. I'm going to just check the lengths, and then I want to make sure it's square and set it up on the shaft. So I've got this driven on, not on the machine, took it off, and if you remember, I got that to center, and now checking between the outside of here and the outside of here. There's a difference of 7 thou, which they coordinate. They both seem to be in the same spot, so I'm going to leave it. I'm going to set it up to weld it, and we should just about have this done, apart from me making this pin that shows it's supposed to go in. I've completed the weld. Like I said, I force fit it, checked it with the dial indicator on the lathe, and now I'm just going to leave it like this to cool. It's in the vise on the welding bench, and I'll let that sit until overnight. It's almost 5 o'clock here on a Friday. I've had enough for today. One of the disappointing things about doing restoration, especially on something that's old, is the cost of parts. This little rubber boot, which has to go on to the band brake operating arm, when I purchased them back 26 years ago, they were $9, and now they're currently $32. And in talking to someone at John Deere from Moline, because we had problems 26 years ago with some parts, and I asked him about why are the parts so expensive, and he said, well, we produce a tractor, and then we produce enough parts that we think we're going to last for the next 10 years. That's all they're required to do by law, and we set that value, and then we increase the price each year by whatever inflation is. So, you know, in today's market, that you could probably make for 25 cents and sell it for $1 and still make money, but this could have been made many years ago, and Deere continues on with that pricing policy. So I probably could have found something similar, 3/4 on this side, and I size it on this side 3/4 inch, and on this side was 3/8 of an inch. That's to stop any moisture or dirt going into the steering clutch housings. Again, they're dry housing, so we don't want any grit getting into it. But by the time I found something and got it shipped out from China, it'd probably be 3 or 4 weeks, and I just didn't want to wait. I wanted to get this machine together. The grass is growing, the tractor has a blower on it, and I got to get the cab off of it, and I can't do that because my crawler looks like this. So I got to get at this. What I'm going to do now is put the crawler back together, and I'm not going to do a long video. I'm just going to do little clips. Every time I put something on, I'm just going to put a little video clip, and you'll just see it magically coming together in minutes. I'm getting into the final assembly here, installing the engine, and to do this I have this electric hoist that goes up, and I'm using a floor jack on the back of the crawler, and I'm just jacking up under the cleat and getting it to roll forward as I inch into the bell housing. So a little bit of playing around. There's a lot of weight here, so it's going to take me a little bit longer. Working on the oil change, and take a look at this. Nothing tells you got an oil plug when you need 1 1/8 wrench to take the drain plug out of the pan. So all that for a 23 horsepower motor, and I'm just going to progress on that and get that done. Working on this side of the crawler. Oil filter's off. I've just put the hydraulic line on, the high pressure, got to do the low pressure, and the cylinder lines as well have to be connected. The crawler never came with a hydraulic pressure gauge, but if you can see here, this one's got a Canadian flag on it. Not that it works anymore. The pointer just goes wherever it feels like going. They're filled with glycerin for vibration dampening. That's why you use them on something that shakes like a crawler. So I've got this new one here. The system normally runs around 600 pounds, and although they didn't come with it, it lets me know the status of the pump and the hydraulic system. So I just put it on because I felt it was worth the effort. As you can see, the water's dripping on the floor. I took the rat outside, gave it a power wash, got rid of the dirt and the dust off of it, and then I've heated up this joint here where it was leaking, and I have wiped the old solder out, and I'm going to clean it a little bit and try to resolder it. What I've done is I've heated it up, I put flux on it, and then I use some of this electronic solder. I find it works really good. This is an old one. This is from Radio Shack, but it's a rosin core solder. Usually you don't get it anymore. Well, unless you order it from China, and it has a better flux in it that allows me at least to wet it. And once I do that, well, then I can just go back with the new modern solder that they have here now. Again, it's not as good, so I wet it first with the other one, and then I'll put a little bit of this in here to let it flow around it. So after I wetted it with that other fine electronic solder, I've just used the regular solder to build up, give it some reinforcing, and to help give it some more sealing. So hopefully that'll be enough. What I'm going to do now is leak test it, and just with compressed air, all you need is like a 1/4 pound per square inch compressed air. That's maybe not even that much. And use some fantastic household cleaner as a soapy water, and it works really good. So I have resprayed it, or pardon me, resoldered it, and I just sprayed some more fantastic on it, and we do not have a leak. So now I'm good. I can let this dry up and give it a coat of paint, and maybe it's good for another 25 years.